Developers have three modes: happy, that's if the code runs successfully and everything goes as expected. The second mode is neutral, that's if the output is not what they expect or what they want. And finally, sad, when there is an error on a line where there is no code at all. Today, I'm going to be teaching you how to build your very own mood classifier using computer vision and machine learning. At the end, I'll be sharing my code with you so that you follow the same guideline and build your own emotion or mood classifier. Ready to do it? Let's get right into it. Alright, so before we start, the code including every file we'll be using in this particular tutorial will be on my GitHub repository, and the link will be in the description. You can leverage this code and update it, work on it, and also use it as you want. So I'm not going to be coding from scratch. I'll just take you through all the codes. So we'll be using three files, and I'll take you through how everything works. I've done everything so that you can take it on from there, because coding all this will take a lot of time, which will make the tutorial boring in my opinion. Okay, so we'll be working with three files, but before I even introduce these files, let's go through this particular image. So we are going to be using the face mesh data. So face mesh, Google face mesh, which is done by the Mediapipe team. We'll be using a wrapper library called CVZone, which will help us to get this face mesh data in a few lines of code. So this contains about 468 landmarks on the human face, and based on the action performing by the human face, we'll collect this data as to sad or happy, and then we'll put this in a CSV file where we'll read and perform some data cleaning and also train a model out of this data. So let me show you how the CSV data will look like before we go into the coding. So in the CSV data, what you are going to create is that because you have 468 landmarks, we'll have the first columns here, or our headers here, to be class, and this particular rows will take in the classes we are going to be taking the data for. Then this will be x1, y1, all the way to 468. So you can see up to here 468, because you have 468 landmarks on the human face. So that's what we are going to be doing. And for the classes column, you can see we have class for happy, and when I come down, right, you can see we have class for sad, and you are not limited by the number of classes. You can actually take many classes as you want. You can do happy, sad, neutral, anything at all you can get from facial expression. You can add that class to it. The possibilities are endless because of the flexibility of the code. So I'll close this app, and now I have three Python scripts: datagen.py, training.py, and test.py. So the datagen.py is responsible for generating the data for us. So for that, we are importing these libraries, and all the libraries you need to install are here, which will also be on the GitHub repository. You need OPCV, Python, Mediapipe, Pandas, CVZone, and NumPy. Then we use scikit-learn to also train our model. We use some of their stuffs to train our model. Okay, so we are importing CVZone in order to use the face mesh detector, and for that, I'll take you through how to get a face mesh detector, or I will even take the code line after one line after the other. So this is the path to our video. We have two video files here, happy and sad. And happy right here just contains scenes of people being happy or people living in their happy moment. So you can see the facial expression. This lady is very happy, this man is happy, and so on. So I just took some couple of videos and compiled them together. The same thing applies to the sad video. Just some video of people being in their sad moments, which is weird though, but we have to do it. So now that you are familiar with all the files, let's start off by looking at the datagen.py. Close this off, and we imported our libraries once again. Then we give the path to the video file. So if you're using your camera, you make sure you put the index of your camera here, that's 1, 0, and so on. So if it's 0, that means it will take your webcam associated with your computer. But if you have a USB cam you want to use, then you should start from 1, 2 until you get your camera to work with. So since I'm using the video SAD here, all I have to do is to specify the name of the video, and that's video path, because that's video path right here. From there, create an object for the face detector. So face detector object, so FMD, which I'll be using, which stands for face mesh detector, is an instance here of the class face mesh detector. And over here you can specify some couple of things such as the max faces, so the maximum number of faces you want to detect. So if you put 1 here, that means it will only take one person's face when multiple people are looking into your camera or your webcam. So you can specify, or you will leave it so that it picks everybody in that particular frame. Then the next thing is to define your class name. So since you are doing it for a sad.mp4, then the class name should be sad, so that in our data.csv it will be stored there as sad. All right, let me uncomment these lines. So what we are doing with this line is to create our columns in the data.csv or in our data file. So with this, first we specify our class. So we'll create a particular column in our data called class. If you can see that right here at the top, let me scroll. At the top here we have class. So the first column should be class, then followed by this x1, x2, which are the data points. So that's what we are doing. We'll create our first one, which is class. Then for the x1, x2 or so, we look through them and create them using the normal Python formatting. So we have 468 landmarks, then plus our class name or the class column making 1. So we add 1 to it, which is making it 469 in total. So that's what we are doing, creating the first header names right here. Then after that, when we run the code, we want to put that header name in the first column of our data set. So we do it once. That's why it's not in the loop. We do it once here. So what we are doing is that first time we run the code, these header names right here, this first line or first row of names, we put it once because we only need it once. All we need down here will be the data and their corresponding class name. So that's what we are doing it here. So that means when you run this code once, it will create this header for you. So after that, you need to comment it off because you will not be creating header anytime you run the code. So once you run this once on your sad video or any video at all, you need to comment this one off. Okay, so after this, we are doing while cap.is open to get our video feed from the camera. So we are just getting it. Since it's a video file, we want to get it in a loop. We read it, we resize it, and then now feed it into our face mesh detector. So we are calling it frame. So we are feeding this frame into face mesh detector, and this will return us our faces. If any faces has been detected and there is a mesh on it, to return us, and it will return us our image too, which is the same as our frame. Okay, so right from here we'll check if we are getting some faces. If you are getting some faces, we take the faces and then we take the data. So this face mesh data will come in a list. So we are converting it to a list, and also we are making it a one-dimensional data or vector. That's why we are using dot flatten here, which is the same as dot reshape into one long giant vector or array. Then we are inserting the class name into it. So we are taking the face data here and we are inserting the class name at the first index. That's why in the CSV file at the first index here, you can see the class. So we are inserting the class name here. Then what follows will be our data. So we take our face data and then we insert the class name into it so that we can select this class name if we want to pre-process this data and train a model out of it. So that's what we are doing. And after that, we are writing this to a CSV file, and the format here, pay attention, we are appending it. That's the mode. The mode we are using here is that we are appending, so that when we take data for one class and we are coming to take data for another, it will not override that. We will append that. That means it will go down. We will be adding to it. So we are just writing it to a CSV file called data.csv, and our delimiter we are using comma. So comma separated values. After that, we are showing our frame so that we can see it and collect our data. So that's all this data generation script is doing. If you have anything to do with it, you can advance it to do your particular task in hand. So let's run this and take data for the sad class. So before you run, make sure the class name is sad and the video you are going to do is also pertaining to sad. So right here you can see we have our video feed. We are collecting data for the sad class, and you can see we have the data.csv file being generated right here. So this will take some time to generate data for the sad class. So just like this, you are done taking data for the sad class, and that's how we take data. So the next time you run this script for another class, you need to comment this line of code so that you don't overwrite the column names again, because we don't need that again. So if I want to take data for happy, I can just now change here to happy, here to happy. So let me do that. So happy.mp4, if I could spell that correctly, and then here should also be happy. So happy.mp4, that's the name of the video right here, and the class name is happy. So that's all I'm doing. I'll run this once again and it will start loading data for the happy class. So this is like a whole data collection process. And just like that, we are done taking data or collecting data for the happy class. In case I want to take data of myself or from my webcam, all I'll do is to replace it with one. So I'm going to collect data of myself being happy, and let's see how it goes. So guys, this is me right here being happy. So just as I'm talking right here, I'm collecting data of myself being happy. You can see it, right? So I'll do some for sad too as well. Add data of myself. You can mix the data up, it doesn't matter. We just use the class name to select them from our CSV file. So that's it. Right here, I'm collecting more data, and I think it's enough. I will do that for sad too as well. So to collect for sad, I just have to change the class name to sad as well and collect data of myself. So you can add your own data to it if you want, or you can even use your own data from scratch. That means you are not going to touch the video path variable here. All you will do is to change the names here, and then take data for that specific class. So you can add your own class, whether you are smiling, you are angry, you are this or that. So now let's do it for sad. Let me run it. So this me being sad. So I think it's enough. I think it doesn't look good. So now that's it. So that's what this script is for, generating data, and we've generated the data, and here is our data being saved here. So we have ton of data, we have many rows. So it's about 4,000 plus. So I think that's enough. So the next script we'll be working with will be our training.py. So this is it. So over here we've imported pandas, and pandas is for data manipulation, cleaning your data, structure your data, rename columns, check info about data, and so on. So we use pandas to structure our data, to clean our data, and then use sklearn, which we are importing so many stuff from here, to train our model, split our model into train and test set, and train our model. Then finally we use the pickle model from Python. Is inbuilt to save our model so that we can use it later on. Okay, so over here we are reading our data.csv. So pd.read csv, and we are assigning the data to df, which is data frame. Then after reading this data, there are some steps we can perform on this data. Data.head, this will give you the first 5 rows of your data. Data.columns will also print all the columns. When I run the code, you see all of these steps. Data.info is going to give you some information about your data, your memory usage, and some additional information. Then if you want to perform some statistical analysis on your data, we use the df.describe, and this is going to give you the mean, standard deviation, the first quarter, second quarter. Okay, since we have a lot of data points, we are using df.dropNow here, which will clean off all other columns that we have no data. So if there are columns which have null values, you are going to clean them off and use the columns that we only have data for. Then the next thing is to go ahead and separate this data into our features and our labels. So the labels are our targets. We want to use these features to predict our targets. So our labels here is our class names, and in this case we have only two class names, happy and sad. So that's what we are selecting here. We are taking the data frame in the index of this particular class, and for our features we are just dropping the class, so whatever is left will be our features. When we drop the class, then from x1 up to 400, all the 468 landmarks will be our features, which we'll be using to train our model. Over here we're just printing them to show. The next thing I do on this line is to split this data into train and testing partition. So we have our x train, y train, x test, and y test, and we are using the sklearn train test split function to do that. Okay, so after splitting this data, we create a model pipeline. So we are using standard scalar to normalize our data, and also we are choosing the model to logistic regression. So with this particular pipeline, it's very easy to switch between different models. All you need is to type the name of the model here. So let's say you need a random forest classifier, you can just type the name right there to change this particular model. So you can test other models to see their performance on your data, and then you use the model that best fits this data for you. Then we use the pipeline.fit in order to train our model. Then after training the model, we are running tests on our test data. So model.predict. Then the next thing is to evaluate this model to on our test data. So we are evaluating it, and we are getting the classification report. This classification report will give you information such as the F1 score. You also get the precision and the recall. You get the accuracy and so much more. So using the classification report from sklearn is very helpful. Then after that, we've done training the model, so we have to save this model, and that's what we are doing here. We are using pickle to save the model. So pickle.dump, and then we are writing it, so write binary, and then we are dumping it. The name will be model.pkl. So after running this code, we expect our model name model.pkl should be saved in our directory we are working in. So I'll just go ahead and run this code. With just these few steps, you can see we now have our model.pkl here. That means this is our saved model which we can use to run inference. So let's go through some of the things it has printed on the terminal. .head, which gives us the first 5 rows, and then also we have the info. So you can see over here we have some informations about our data set, the memory consumption of this particular data set, and some other informations. For the columns, so we have all the column names here. So the terminal cannot display all, that's why you have the dot here, but it gives you from starting to the end. Okay, so here is where we are doing the data.describe. You see you have your mean for each and every column. So you can see x1, you have your mean, you have your standard deviation, after which we also printed the features and the labels as well. So we have the labels, we have our features. Then over here we are testing our model on the test set. So these are the predictions from the model on the test set. Then when we come here, this is our classification report. So you can see we have the precision, recall, F1 score, and the accuracy for this particular model is 100%. Wow, that means our model is very accurate on our classes. So you can see the happy, for the happy class, both precision, recall, and F1 score 100, 100 are the same thing. That means the distinction between our model on our classes is very great. So let's see whether this model can generalize in real life, where we are going to run it on our webcam to take our webcam feed in order to classify whether we are happy or we are sad. So for that, I have the test.py here. So with the test.py, we are just loading a feed from our camera. It's just like the data generator. So feed from our camera. Then over here, we are loading our model. Then we process this feed just as we did in the data generator. We also flatten it to be a long list. Then we are feeding that face data into our model to give us results which will display on the screen. So that's what we are doing for the test set. I think it's self-explanatory. When you look through, you can see similar to the data generator, but instead of saving the data, face data, we are sending it into our model for prediction. So I'll run it, and this will run and open my webcam. So I've specified my webcam here, one. I have a USB webcam attached, so I'm using one. If you are using your actual computer webcam, then this should be 0. So let me run this, and let's see how this model performs in real world. So guys, here am I, and you can see I'm in the happy mood, so it's detecting that I'm happy. Let's try sad. So I'm sad. I'm happy, and you can see. So I think this works. This classifier works. You guys can go ahead and add additional class to it to see how it performs. And also, I'll be sharing the code and every other file you see here in this particular tutorial on my GitHub repository. So just check the description of this video and you can have access to it. Guys, this is all for today. You can either be happy, but don't be sad. Be happy and make things work out. Thanks for watching, and if today is your first time, make sure you subscribe, you share with your friends, and up until then, I'll see you in the next tutorial.